both it'll let you know stuff both on the Java side with the exceptions and things that it's throwing that it catches and keeps within Juxta, as well as the like all the Juxta events. So you can see if stuff's actually talking. So like if something happens on one screen
Oh,
and
really?
yeah, and stuff pops up
Oh
on the
man,
other.
I could use that
Yeah.
yesterday.
So
Alright, how do you get Microsoft?
so it'll show you like, and they're actually really long traces. So some of them are. Oh, shit, close that. And this actually can help with non-juxta related programming too, because you can see if you're, like, especially if you're testing remote signaling, you could see if your signals are going through. But this is what kind of printouts that they have. But as I said, it's very verbose. Um, so it goes down to even like the XML that it's sending, like what it finds. So you can track
Yeah,
down a
because
lot of
like I
stuff
think
there.
one problem I ran into, I think I was accidentally sending, I don't know, I was sending a message. And I was sending a pipe in the message. I don't know what's wrong with the message, but it just didn't get there. I'm like, well,
Well, you got to make sure that the other side. I mean, and I don't know. Even without the debug, uh, I mean, you need to print out do some print messages to make sure the other side, that the other side is subscribed to it. And sometimes that's hard to get it to do because, and this is also kind of related to some of the stuff I think we're gonna. If you haven't run into it, I think we will run into it as well with stuff like Quitter. Let me pull up Quitter. Okay, this will happen a lot on both sides because one of the things that you guys need to keep in mind when you're doing this stuff is what threads are running. Okay, what threads you actually have code going through because, and especially with signaling, I don't know, signaling, it starts to get really hard to know what thread is actually processing the signal. Because to us, we think of the signals as we put them out there and then they go off and get processed. That signal gets processed, and in a lot of ways you can think of it just in that way of I go to the queue, I get a signal, I process it. I get the next signal, I process it. But where you really run into problems is things like wait or with juxtas threads running on its own or the swing threads running on their own. You need to really distinguish between, like if I'm programming a GUI or a console, which is my thread, my swing thread, and which is the application thread of pace, and which is the main event queue of pace, because those are at the very least the three threads that you're running, right? You're running your application thread that was given to you by the application launcher, or by virtue of being an application object, loaded from an application object. You have swings thread, or in the case of like a console or Juxta, their thread, and then the event queue is its own thread as well. Okay, so for example, let's say I request a quit, right? So I request a quit, and that's slotted here, right? This request quit slots here, right? So then I'll start processing this, okay? What threads are we in right now processing this? But what thread is quit running in? In what? Yeah, the the pace event queue is where it's running. Okay? Because we know this because of this. Quitter, okay, is using that event queue. Quitter is a application module or an abstract module. It is not its own thread of execution. Right? Application is its own thread of execution. So there's no other thread that is contained in except for, well, actually, Reed makes a good point. It could be main as well, but main is really done almost immediately down to here. Okay, basically main just joins the event queue's thread, so it just sits there until event queue's done. Okay, so um, we are in quitter is in event queue's thread now, and that's where a problem could come up, because if I'm running the quit method, right, and I run through and first of all get to a loop, for example. Um, if there's a loop, the duration of that loop, we will tie up event queue's thread. Okay? This may or may not be problematic, but it usually is problematic in the sense that if you emit anything, event queue will not process it until this loop is done. You will emit it. It will go into the event queue. But if you're expecting something back to break you out of the loop, you're deadlocked. Right? What do I mean by that? You're waiting for something that someone else is going to send you, and that someone else is waiting for the signal that you just emitted. But since you're the thread that would process events to get to the event you emitted, you're deadlocked. Both of you are waiting on each other. Okay? The other thing is that waiting within an event queue will wait the duration of that, and only things going on in other event queues will happen during that time period. Nothing in main pace event queue will happen here. That's not always a problem, but the main event queue is one of the ways that we communicate between different threads. In other words, if Juxta wants to talk to the GUI, it has to go through pace event queue. If an application wants to talk to the GUI or Juxta or something, it has to go through main event queue. Okay? So, what can we do instead of this? What we need to do is we need to be able to get out of this method so that the main event queue can churn, and then we just want it to come back to us. Okay? So, how you do that is using using delayed events. Okay? So let me give you an example. Yeah, you set delay. So, but see, then you write another method to catch. See, in other words, what you do is you wrap everything on this side of the wait, you put in here. Everything on this other side of the wait, you put in another method or in another slot. Okay? But the main thing is normally you should not need loops within slots. And I say that in the sense of you shouldn't need to keep doing, I mean, like, yeah, you need loops to go through, like, iterate through things, right? But you shouldn't need loops to, like, keep doing something, right? If you want to keep doing something, then you should keep emitting a delayed event so that you can catch the other pieces. I mean, so that your thread can churn and you can maybe catch the things that you might be waiting for. So I think I did a lot of that in Juxta. Like, for example, the intuition for doing something like polling, right? If you want to poll something, and that's essentially what you're doing here, right? I didn't really read through all the code. You're really just waiting for everybody to report back with something so that you can do the final quit. So what you're kind of doing is, normally it's like polling. You're saying, "Are you done? Are you done? Are you done?" Except you're doing it, in what intuitively seems more efficient by waiting, because what you do is you're not busy waiting. You're not sitting there going, "Hey, are you done? Here, are you done? Here, are you done?" Right? So something like discovery, like when I go and poll all the, poll paste to see are there new remote ads, that is something intuitively we do as a loop, right? To poll. So instead of that, if we do that, we'll tie up all of Juxta's event queue. Right? I mean, all of Juxta's thread, its application queue. Okay? So, which may or may not be good, considering if we know what we're doing, it's all right if we tie up the queue, because we know what the rest of Juxta is doing. But sometimes it's not good in the sense that Paste may want to tell us something. And until we start processing the event queue, we'll never hear what Paste is telling us. Like, for example, Paste might be telling us to quit. So we wouldn't know until the next go-round of looking through the queue. But notice here, I do a slot discover, which gets the Paste discover, right? So one iteration of the loop is running through this, right? But before I leave, I emit another discover with a delay on it, right? So then I can leave. Now, any events that have queued up or anything like that, they can start being processed, and I'll be put in line or whatever. They'll start being processed, and that might go off into other objects and things. But as long as they don't hold the thread, it'll get through the queue and eventually come back to my delayed event, which will fire. See, and that's the reason that this delaying mechanism, why I added it in, because there's not really another way to make that happen without running tight loops, right? And there's no way to have the application object delay it, right? Because if the application object, the module delays it, has to tie up the queue, right? And there's no other way to put a wait statement into the main thread of execution. Okay, so what this delay piece does is it puts a wait in there. There's just a conditional in there that says if you're delayed, you're the only event in there, I'll wait for that period that you're telling me. Otherwise, I'm going to churn the rest of the event queue. And it might be helpful to look at it's an event queue actually. All right. If you look at the loop, okay. First of all, let me start up here. Okay, if you're empty, we can wait. That's woken up. If you ever do wait, especially if you wait indefinitely, you want to make sure you have a notify somewhere to let you know when it's going to wake up. Right? If you put a time in there, you know when it's gonna eventually time out, and then you'll be able to move on. I grab an event. If the event is ready, and that's governed by delay. Is ready is checking, is the delay time past now? Okay, because what delay is you set it for an offset, like 5,000 milliseconds or whatever, and it will add that to the current time. So then what it stores in delay is the time that you want to run at. So is ready returns whether or not we're past that time or not. Okay? If it's not ready, if the queue is empty right now, and the only event we have is this delayed event, well, we can wait until it's ready. Okay? And we don't really have to worry if another event comes along. Right? Because if another event comes along, this wait will stop because of the notify. We'll go back through the queue and grab the next event, which in this case would be the delayed event, but when we get back to this point, the queue will not be empty. So if it's not empty, we'll be able to process the next event and keep going. See, because if it isn't empty, then we'll just re-queue the event. In other words, put it at the back of the line so we can start processing other events. Okay, so first thing, a console.
I think I already know what I did wrong.
Yeah, so that's probably related.
Well, also for the slots, like so, I was gonna catch that load application signal, right?
Right.
And then it would call my run main. Run main needs to be public.
Yeah. In runnable?
In
In main.
in my console paste console dot console.
Right.
My little guy
Let me check it out.
catches that load app. What I want it to do is when it's loaded, it'll that way. I know
No.
it's loaded because it'll catch that load application signal. Well, it's supposed to.
No, it's not supposed to
It's
catch.
not supposed to.
Load application is the application object.
Okay.
The application oh, you mean load? Oh, you're talking.
Because the application launcher, what it does is when it loads the app object,
Right.
it emits that signal, right? Load
But it
application.
emits it for other app objects being loaded, not for the console object being loaded.
So that's
The
why I
console
never
is an
catch it.
app,
Yeah.
but there's no objects there for it to catch load application.
Okay.
You see what I'm saying?
Yeah.
Because you're in the loading process of the application.
Yeah.
So you might not catch your own load, you'll catch everyone else's.
Damn.
That load application is to let a GUI know that another app has loaded.
Okay. All right.
The other thing is that the event queue is not even processing when you're initially loading until you run EQ start.
Yeah.
No, but what you need to do, you need another thread.
Oh yeah, for input and output and stuff. I was just trying to get. I was like not even worrying about that yet. I was like, I just want to make sure I'm on the right steps to where I can.
If you want to print lines out, you put it in the constructor because that's the only thing you got run. Okay. Now, no, but you can bootstrap an event. You can emit your own event that you want to catch. In other words,
Like, do you see
load me, then emit. Load me, then I'll process something.
Yeah, that's why I thought like.
Yeah. So what you do is you change this to something else, and then just emit it right before you go.
Okay.
Right?
So
Because
I-
that's a way of you saying
So
right after you load me.
Yeah, I'll emit my own signal, which I catch.
Right.
And then okay, cool. All right, I'll get started on that. And then does that main
But see,
function, should that be public? Or
What?
Should that my
All slots should be public void.
okay, not private. All that other stuff is just copy and paste it from.
Didn't you specifically ask me like why wouldn't this be catching? And one of the first things I said was make everything public
Yeah,
void.
I was not really.
And
paying
then you-
attention.
Yeah.
I had to start doing something
Yeah.
else. I had to finish my computer.
Alright.
I know. As soon as you said that, and I signed off. I was like, "Did he?" And I like reset my computer, and it had the logs, and I was like, "No, I don't want to ask again." And,
Right.
Like, stupid.
So you need public void, and then you're gonna need another thread. Why do you need another thread in the console?
Because I need to do lots of stuff.
No. Why you only need a thread for one reason? Why is that?
For my input and output, and
But why?
because
And it's not really for output.
for the input, because I'm gonna be having to input things at multiple times.
No.
No.
Only one time is when the user gives you something. But why do you need a thread? Because it blocks.
Blocks.
It waits. When you try to get input, it's going to wait for input. Either that or you're going to have to go pulled, but even then you have a problem. How are you going to pull it? Okay? One option is the most inefficient option, which would be continuously emit delayed events to use the main pace event queue to pull the keyboard. That would not be good. Okay? Running another thread, then you can do whatever. You can do that as inefficiently as you want. If you want to pull, if you want to wait, if you want to block, whatever, you can do that. But what you need is another thread to generate pace-based events from the input. So you can have a continuous loop grabbing input and then just having that continuous loop just pop stuff into the event queue.
So should I just subclass thread for like IO thread?
Yeah, like have like an input handler or something like that. Make that runnable, right? Make that a thread, and have it go over here. You may or may not want to do any kind of internal event handling. If you don't want to do any internal event handling, you could just also make it a signal emitter. If you make it a signal emitter, you may or may not want to do that because then it's a matter of emitting directly to the application queue, which I don't know if you want to do. I mean, depending on what kind of events you have. For example, with Pace GUI cheats.
Yeah, I looked at it.
Because Pace GUI has the advantage that anytime you create swing stuff, it sets up the swing thread, the swing event queue infrastructure.
Yeah.
So you don't even have to worry about it. I mean, the thread is automatic, but the idea is the same. You have methods that you want to call based on these other asynchronous events that are outside of Pace, right? So we do the same thing here where these methods right here, like these types of methods, these are bridges between the swing the event system and the Pace event system. Okay? So I catch something, I fire an event. Well, that's firing a swing event. I run my listener, I fire a Pace event so that can go off, go do some stuff, and then hit our slots on different applications. Okay, so at the very least, you know you want bridges between these events right here. Um, oh, also another thing is you are, like I said before, you're welcome to also tie up your own queue. I think. Don't we have an example of a? What file was it? Name.
Which file turn change for Evo?
The platform config in the .jxter directory. Main. Okay, so it should be a very early version of main.
And then what's the tag that I'm changing?
DBG, I think.
Oh, man, now that makes sense.
Yeah.
With the whole load application thing, because in the GUI, when it catches that load application signal, it updates the tree.
Right.
Which would mean that the other apps are got it. I'm smart.
The one that's emitted for you, nobody's there to catch it.
Yeah.
See this right here? This is what you want to do. Okay? It's a thread that's also a signal emitter. It has signals that it emits, and then it does this nifty stuff. But notice, it's in its own runnable, right? So that it can get spawned. But this was back when I could start on my own because I just hard coded it in. So the difference would be your app, you have a kind of a platform. You have like the base where you create this other object which runs a thread, but then you just bootstrap by starting the thread with this other object. Okay, then it will run, and then the other thread will run. Now, what other stuff are we running into with like the quitter and whatnot? From application launcher? Okay, so you pull. Do you like ask it?
Yeah, there's another that was originally request quit style, and it goes to application launcher.
Is it catching anything right now? Like the
Yeah,
request quit right here.
Gives you back the just the list.
Okay, so the app list.
And that only holds UI and the net, the two default things. It doesn't hold parameter sweep.
Okay, so you've loaded an instance of parameter sweep.
It doesn't.
Okay, so you have an active group. In other words, you've already created a group, and it's loaded, and it's sitting there with the start button available. And you're not seeing it in that.
Wouldn't it be because the GUI creates it? Wouldn't its parent be the GUI?
Because the GUI just asks paste to create it.
Okay.
So I mean, it goes through the same thing. App list add group. Okay. Does it do? I mean, it attempts to do it now. If I quit, do you have like a printout of saying?
This will get the brain version.
Did you check in the branch? And this is on Pace. Here's a branch of Pace.
It's 20.
Going. Oh, over here. I don't see any branches. Hold on. You guys committed your branch after you branched?
I did.
No, I see a console branch.
I was here when we branched. Did you? Didn't we do it on Thursday when we branched it? Well, this is what we had. Oh yeah, that's right.
Because if you branched and then didn't commit, you might still have the branch sitting on your machine. So I don't know. All right, let's see what happens. When does it? What comes back from enumerate modules? Apps request quit. This one, right? So quit, right? And then commit save. Okay. We enumerate through the apps here. Oh, down here as well. That's just a what? Wait, what? Yeah, I'm just boolean so you can keep them, right? So you can track them. Okay, but I'm just gonna print it out here. Because again, oh no, you return. Oh, that's only if it's empty. Okay, but everything up to here, even though we're emitting and things and whatnot, we have to get through all the emits before, we have to return execution back. Um, module. Huh. Get app object. Do we have like a name or anything? Yeah, but that'll. Are they named in any way?
Get name? I just saw get name in there.
Oh, it's a thread name. What does toString look like? Or just be an object? All right. Did you get my post, Nick, about moving debug stuff out?
Was that on the wiki?
Yeah.
No, I haven't looked at the wiki.
Let's see.
Which debug stuff?
I want to move the emit and catches into the application modules and have it be a flag. So in other words, have abstract object provide a service of debug messages that it'll only print if the debug flag's set. That way, because I think the debug messages are very helpful for while we're developing. But like I was running like my cluster, which does like 1,000 loops or whatever, and then it was just dumping all kinds of stuff. So okay, we have a where it's running. I don't have any groups loaded. I'm gonna quit. Okay, That's it. We didn't print anything, did we? Alright.
Oh wait, sorry. Yeah, this is the lowest version. They got the technical ad slot.
The which one? Oh, this ad slot? Oh, you faking.
That'll actually register. Which is crazy. Took me about an hour to figure it out. Wasn't that the one when we were in here? Like the next day, you're like, dude, we just had stupid stuff that we put on. It was fun. We're working in here. Software engineering class going on. I get up to leave. Lady's like, class isn't over yet. No, I'm not.
Alright, so we're in there. I'm going to quit. Null pointer.
Nobody ever went
Oh,
Oh, yeah, change it. Man, never really wish I put it together. I made that a list. Perfect. Just take that out.
wait for this group to load. Alright. Okay, so, oh, wow! That's awesome.
Yeah, I figured out that problem.
Alright. How not to go into infinite loop? Yeah.
Yeah.
So, alright, so let's see here.
That's pretty tight.
That's pretty sweet. Alright, hold on. Alright, so we got a bunch of loot and it kind of covered our little debug messages, didn't it?
Sweet.
Okay, so 2 threads, and then, oh, it's because you're trying to wait?
I did thread that way.
Yeah.
Commit. It's time to commit it. Committed your work. Unlike me. Like,
Okay, so we have 2 threads there, right?
I gotta run that video.
Okay. So that's 2 threads. Let me join this. That should create another application object. Okay, so I have thread 22.5 main. Alright? And let me get prepared to break. There we go. Quit. Alright. And then there's 3. There, problem solved. They're all there. So, what I'd recommend, break it into 2 methods. This part of the method and this part of the method. Okay? And replace the wait with a remote signal.
Delayed signal?
Yeah, the delayed signal. Not remote signal. That would probably be problematic. Okay. What else? Anything else running into?
What's left for us to do with parameter sweep? Just handle it remote. Handle remote. We got all our stuff saved up. We're saving quit it.
Where are you guys storing all of that?
The parameter sweep stuff. It's up there.
No, I mean, where are you storing like state information and stuff like that? Do you have a directory structure yet?
Yeah, Where we put like our serialized files.
Should be the root file.
Yeah, it goes to
Two directories up from the base directory, source directory.
All right, no.
Should just be
Hold on. No, it's got to go down directories. I mean, it should be up and then down. It should be up some directories. Okay, because we need to think of this about, we need to think about what will the app look like when it's running for real, not in these subdirectories to do development in, where we need the source files and everything. Okay, so okay.
guacamole.
What would this be under? We were doing. Well, we were talking about. Oh, directories, right?
I gotta sign in. I haven't signed in in a while. It's been a while. Really? I only got the one.
Are you watching anything?
I think. Maybe not.
Yeah.
I thought it would automatically email for a message. I'll set it up.
So that.
So go up the pace, drop it.
Okay, because what will this look like? When you want to run when you want to participate in Pace, you'll get a jar. You get a Pace jar. You'll run that. It should be able to bootstrap into some sort of basic configuration. And then from there, what would you do? You'd be looking around the Pace network, joining projects and stuff and running them. Okay? Well, how are you going to get to that stuff? I mean, like, where's it going to put that stuff? Well, if we have like a Juxta file management system, it can dump all its stuff into files, right? And that will kind of be the like that's the class path almost for like where we. It's not going to be in the class path because we're going to explicitly load any jar that we want to work with, right? But then we'll grab it from there. But our working directory is going to be Pace, right? So if I'm an app, I need the app launcher to put me into a directory and basically rebuild the group structure, the group tree, right, the group model in directories. That way we can have all the app state in there so that if we stop, if we close Pace, and we load back up, we can go create a group for every directory and then reload the state of all the objects that are in that directory. Okay? We may need some basic stuff in there that has like application info or anything, or that might be in the root kind of configuration XML file or something like that. Or an XML file that has the basic configuration and then another XML file which says all the projects you're in. Okay? So this will be the state saving stuff, and then when you leave an application, when you explicitly quit an application, you should be able to clean up any stuff that we have in here so that next time we boot, we won't try to load that state information and everything like that. Okay? So what I was thinking is that you have the client directory, and this is where the Pace jar itself is. Then you have a directory under that, which is Pace, which corresponds to that root Pace group, and then all the app groups under that, and then files inside them that are these other things. Okay? And then another kind of sibling directory to Pace would be something like the file directory, because that could be separate. Okay? Hey, let's see what else we got on the wiki. Okay. Config stuff. Oh. this is something that we're going to need to eventually address, and that is any additional jars that you want something to load. Like, for example, paste juxta right now can only load juxta because we're cheating. Okay? We're cheating this way. This is how we're cheating. Right? Because those libraries are set for the basically the main class loader of paste, when we go to load paste juxta, we can find all those jars. So how should this actually look? Well, paste juxta should have dependency jars here, which, as far as I know, I think there are mechanisms in the class loader object and where is it? The application launcher, I think. If I'm not mistaken, there are methods in the class loader to add additional paths. So you should be able to do that with Juxta. So the idea would be that it would be nice if we could just give them a jar which just has paste in it, but that doesn't have any networking, right? So what we need to do is have the base application have a little bit more, which would be paste Juxta, probably like a GUI, right? And then an XML file config, which defaults to loading those. In other words, having this stuff in it, because we're going to take this out, right? And then this will just be an XML file which says anything that you see in the XML file, you're going to load like that. UI, network, whatever. You can have it load whatever you want, so that'll just be a list, and then you just have to have the corresponding jar. So what would an installation look like? It would look kind of like an installation would basically be, come on. An installation would basically be the client directory, probably the jar in that directory as well, the paste jar, an empty paste subdirectory, and then a files directory, and then under the files directory you'd probably have paste juxta and paste GUI, right? And then in the client directory also would be config.xml, which has load these two jars by these two names. And they're somewhat unique in that they are kind of null applications, in that there's no other stuff you need to put in except for the path. In fact, we don't use these XML files at all, right? We load these by pointing directly to the file, which I think is good. I think having jars that you can just throw at paste, and it can load them as just null application modules which don't take any parameters or anything. They can optionally take parameters, but you can also just throw the jar at them and it'll load it. This would be good for things like GUIs and reporting things or whatever. Okay, because you can just hook them in, or like monitors or stat monitors or something like that. You can just load them in, and they'll get to hook into the event queue, and just mainly their receiver types of things, where they want to just watch the event queue, maybe throw in a couple events of their own. All right. And okay, and then the file management for you, Richard, will be basically you are going to be populating this files directory, this separate directory under paste, and that's it. I mean, once we can interact, you'll be the interface for that files directory, which has all these jars that we've downloaded, and some way to track them, resolve clashes, and stuff like that. So now, if we have that interface, we can replace this right here, right? When we're getting this jar path type of, this getting the jar path stuff, now we have a frame of reference. Now we can know that it's in this files area, and that we know where to grab it. We need to I don't know. This might be problematic. This having the jar be in the XML file, just from the standpoint that we don't know what the jar is going to be named, because we may have needed to rename it. We may have needed to do something else. But this getting the path will do in some way. Like this might have like a symbolic name that this application is known as, and then that's basically what we're going to ask the file manager for. We'll say, file manager, I need perimeter sweep.jar. It might not actually be named perimeter sweep.jar, but we'll know it as perimeter sweep.jar, and we can pull that file, return that, and then load it using the application launcher. Okay. What else? Issues. What other issues? Uh-huh. Okay. Is this in okay. Um
I can send a string message element. You know how you have a pipe and you add you have a message. I add a string message element, it works fine.
okay.
If I add a string or a byte array, then the listener just doesn't pick it up. And I was just looking at the debug and it threw an error at me. It threw it.
Or a byte array? You can't even send a byte array?
When I did a byte array message element and I give it the file name and the array, it doesn't pick it up when I add it to my message.
Are you doing it like this?
Alright, see, maybe I can look at here. It's probably easy. Oh,
It's not that.
let's see.
But
Output pipe listener where.
wait, hold on. All my object serialization is byte arrays. So don't resolve problems that are already solved. Get familiar with my code, Richard. This works, and this receives events and churns events. All right, you need to do the design like this. You need to do the design where you're taking advantage of both event queues. Okay, so senders, again, just like with your problem, Nick, you need. Okay, well, I mean, but still, you should be able to churn events. The at least your own events. The you want to launch from something else. So this pipe sender happens in groups, I believe. Open. Okay. So basically, you want to use an object to kind of be the launching point for these other pieces, where you launch them so that they can do all their asynchronous stuff, like the juxta stuff. They can churn through events, and then you can bridge between them and your main event queue. Okay, so if you want to do this outside of Pace and do it like, no, I mean to experiment with doing like file transfers and whatnot, then what you do is you just follow. The easiest thing to do is look through the basically, our apps are taking something that is, that we think of just as sequential, right? And then breaks it up into little modules, methods, slots, and then they start getting glued together by signals. So if you want to do any of this stuff outside, you pick apart the parts that are pace, look at which signals emitted and which caught, and then just cut and paste them together in your code, right? And you just walk through from beginning to end. So and the same goes the other direction, like with quitter, like that loop that we had in there. Well, that's how you think of the loop. And then all you do to pacify it, right, is at any point where you want to wait, where you want to loop or something like that, where you want to loop something not in the sense of enumerating, but loop in the sense of doing something over and over, you just cut it at all those places, put them into separate methods, and then glue them together with signals. Okay? And if you want to go the opposite, like to experiment with like file transfer and stuff like that, you take all the different methods that are out there, find the events that are firing between them, and glue them together. And then you'll also start running into, where am I going to have problems because I have two signals going out? That's something that we get to uniquely do, are these signals going to multiple places, and then oftentimes even getting into separate event queues, which is where we start getting our power of this asynchronous stuff going on, where stuff's going on in these other event queues while I'm doing my stuff in my event queue. I have Juxta, its own event system, which uses, this is part of the Juxta event system, this output pipe event. This is not tied to any pace signal. Okay, output pipe event is tied to, should be something with this, but output pipe event is part of the output pipe listener interface. Okay, and by running some of these methods, might be on the other side. I don't know. Is anywhere where it says this? No. It's probably a remote signaler. No. Yeah. So here, this create output pipe and this, that takes advantage of the pace. I mean the Juxta event system. I've added it as a listener for this output pipe that's created. Okay, so now Juxta, outside of any of our threading and event queue, can sit there and run this method whenever it, I don't know, whenever it can. Juxta does it by, if you set up an output pipe, it makes it event driven because you don't send it synchronously. You don't sit there and go, I'm sending it right now, and then when I'm done sending it, I can move on to something else. You put the pipe out there, and then when somebody contacts you, you emit it. Because it's kind of like if you're on a network and some people got the broadcast, but somebody else might have just come up, or they might be on another network far away, and they want to poll you instead of you pushing to them, or something like that. So this makes it so that there's always a message there to send out and receive, at least until you start changing some of these pieces. Okay? So that, and the other side of this pipe sender is, have you looked at any of this, the pipe receiver as well, Richard? Because that has the kind of the other side. So this is kind of the client side. You should be able to see some of the.
Okay, that's exactly what. All right, I'm doing exactly what you're doing.
You're not doing exactly what I'm doing.
Well, not in pace, but I'm saying I'm still
Right.
not receiving it. Like when I add that byte array, I still don't receive it from my listener.
Okay, then something's wrong in your subscription side, which would be.
But if I take out the add, if I don't add the byte array message, then and I just add the string array message, it works. But if I add the byte array message to the message, then it doesn't catch it.
All right, check in your code when you get a chance. You can check it in like a separate project, and I'll pull it out. Something's different. Don't say it. Don't say it. Don't say it. Something is different. Okay? Something is different. Nothing that we're doing in pace would impact Juxta to the point that
No.
that it would not allow.
No, it's not. It's a juxta. I don't know. I mean, of course I'm doing something.
Right.
I just don't know what it is.
Right. So check that in, and we'll see what's different as far as the message elements. And you're adding the message element exactly the same way like this.
Well, I actually read the file. I mean, from the file into a byte array, but it's a byte array.
Okay, and then you wrap it with the where is it? And then you switch it to byte array. You get the byte array output stream.
I just read it from the file stream to a byte array. I don't know.
Oh, into an actual array, not array output stream.
But then when you do the when you do the BLS.2 byte array, you get the same thing. So it's 20 byte array.
Yeah, and then you're putting it in with.
One string element that works when I send it, and then I do message or output as like send, and it doesn't get it when I add.
Okay, so
byte
you're
array.
but you did this as well. This add message element.
I got it right here.
Okay.
Let's see. This one's driving me crazy. Actually, I had a. Like, right. I just been playing with the. But, alright. I read it from a stream into the byte array. And then. Yeah, new byte array message element. And put the byte arrays in his name B. And then I add both of those. And then I send for your part as well. One way. Watch. Now.
Hold on. What's this null?
Oh, well, I guess you don't need that.
What is it?
It's another constructor namespace.
It's a namespace?
Yeah, it's the same thing as the other.
Go to this other Go to this other cost party.
You said when you take out this part. Oh wait, when you take out this part,
It works.
it sends the string, and you can reconstruct the string on the other side.
When I add that one, then the listener never picks it up. I don't know what I'm doing. I think I'm crazy. And it's actually stuffed inside the byte array.
This right here, you check to make sure that there's.
Yeah, there's stuff. It's not an empty byte array. Actually, I should just be sure.
You should print.
Sweet.
Well, I had a print up there.
Okay. So what is this running? What context? Is this just a separate thing?
Yes.
So I should be able to run it right now.
Run.
Oh, you gotta get all the apps resumed.
And then I got one over here.
Did you start that resumer?
Alright, now. Java.
Server?
Shouldn't work. So I got it, and the event number 5. Because what it does, it sends a query, and that's the query somewhere. That's a good, this gets
Yeah,
the
well, the
query,
resume state
creates
in
the
worker,
output pipe, and
it'll
sends it
load
back.
that serialized work unit.
Now comment out that line.
Yeah.
And watch.
Worker has it saved at one. Worker will load up what it saved.
So that
work on
message sent is
consolidator.
that
Yeah, it's the query. It's not
is the query is not the query?
Yeah, it's well, it's not this. That's I got
Jump
queries
starts input
going
factory.
back and forth too. Wait, if you got a
But
query,
how does it know when worker's done? Like we'll try
Yeah,
and
those
send it
aren't
over
related.
again.
The queries, the client can really do
So it does look
Okay,
like
okay, okay.
Look, the query test. I created a query. I had to do it in a separate. What I found out. I found.
There's some query handler. Okay, wait.
Yeah, let's see if it works.
We
always have good theory.
Q is the query test.
Yeah.
Okay.
On
That's
paper.
You can't actually run. You have to run it in your query to find out. When it gets to the end.
Indubitably. what goes where.
It's query test.
Yeah, I had no idea about the load application. I was like, wow. Oh, it's because it's
So you
other
can
stuff
actually
loaded.
believe that it gets it. Let's comment out the add the byte array.
I was trying to think of some reason to explain why you would want to do it.
Alright, we can go to project.
But I couldn't see what else.
This is the one we're running.
Yeah, query test.
I'll work on it tonight. I'll get some basic crack
And
going.
then, well, you gotta copy the files over. They're in a different directory.
Wait, this query test is on the server side as well?
Yeah. Well, no, it uses it.
The server should be fine, right?
No. We gotta. Wait, where are you running the server? Yeah, the server should be fine.
I looked at my bank account last night.
Well,
It
the
was
server
like
only
-13.
sends one stuff. So.
Usually, yeah. Well, I'm supposed to go to Tuesdays and Thursdays, but I haven't. I've just been
Yeah,
calling and
now
saying
the server should get fine.
it's an internship. Yeah. Going up there. I need to figure out how they can pay me when I'm not there.
Oh shit! Now I feel stupid. Oh, it just sent it. Oh wait, it never sent the message. Did it just send the message first time? Query handler.
Client should be run first.
Yeah.
Oh.
Client went first. Oh, did you compile query text?
Yeah.
They're crazy.
Stop that.
I didn't go again. I still live at home. I didn't come home the other day. I was like, where'd you sleep? I fell asleep in the library.
Does that work?
It worked for his wife.
Alright, I give up now. Here, give me a second. 'Cause I swear, it just worked. And it's driving me crazy because I'm like, it doesn't look like I'm doing anything else. Now it's not picking up at all. What'd you do?
I broke it. I mean, did you set a breakpoint in the debugger for the event and it never fires?
Sometimes when I do that, I've done that. Cause sometimes I run the server
From the debugger and then you.
and it breaks if I do it.
All right.
Yeah, I think it just wants to mess up something crazy.
No, but also you might want to try fixing your advertisements so that it doesn't keep creating new ones. I noticed you're generating a new one.
Yeah.
So you might want to fix the ID of the advertisement so that you know that the server is subscribing to the right one and that the client's generating.
Because I'm sending it through queries, like I send from one query to the other.
No, I mean just to test the transfer. I'm saying. So I mean, fix the advertisement so you're always advertising the same one. That way, if there's cached copies, that way the discovery aspect of it you can take out.
There's no discovery.
The advertising and subscribing aspect of it you can take out. There is discovery.
I'm not discovering.
Where are you storing the advertisement? Oh, are you storing the advertisement on disk?
Query, fix it the query.
Well, that's what I'm talking about, discovery. That idea of you're publishing something and somebody's subscribing to it. Well, how if you're not doing any discovery event, how are they finding the pipe?
I'm using the query handler and passing the ID. Like I didn't use the discovery and pipes. I used query and just sent the query to the group, or actually probably to that.
So you're using query handler. Okay, so that discovery system.
Yeah.
What I'm saying is that discovery system you can keep. I don't know. I'm just saying reduce the amount of things that going through that whole query and response thing. If you're having trouble sending any, that's what you're sending. The queries can only handle strings.
It's a string.
A byte array it cannot handle.
No. All right, I start on the
Uh-huh.
It creates a message. It creates the pipe.
Uh-huh.
Then it creates this a string with its ID. Then it sends it to the server.
Uh-huh.
To the client.
No, the pipes that you're using, are they these query handler things?
No. I got pipes and query. I'm using both.
Okay, you're only sending strings through the query handler.
Yeah. And then the string I'm sending to the query handler is to the other one with the ID. Once it gets the ID, it creates the pipe.
The ID of the pipe?
It creates a pipe with that ID that I sent it.
Okay, so you're doing your discovery through sending an advertisement directly to the, not an advertisement, but an ID to get the advertisement on the other side?
It worked.
It doesn't work. It
worked.
doesn't work, okay? Just stop saying it doesn't work. Or that.
Nobody talked to me for like 2 minutes.
Alright,
It
so,
worked. I'm not
anything
using it.
else? Broken?
Spirit.
Alright. Oh,
How long you been doing this? Just so I can know. I have soul crushing.
what's that?
How long you been doing this?
Doing what?
Programming.
Programming anything?
Yes.
Oh.
So I can know why I have like this soul
At
crushing.
least 8 years more than us.
Programming anything a long time.
About 2 years?
Yeah, you know, I took a correspondence course probably 2004. No. But
Yeah.
no, I mean, I've been programming for a long time. I don't do a lot of Java or anything like that, but I don't know. I've been programming since I was a wee lad. So I guess
I got some catching up to do.
Good old filmmaker years. Learned a lot.
Might not like that so much. More than art films.
but honestly the good stuff I got was probably actually during undergrad stuff of getting like some ideas on how to code.
Cluster app parts? Let me see it.
Yeah. Notice what I do first. Oh wait. I have to. It's because I did those edits. Just double check to make sure I am on stable branch. Okay. Clean and build. And is there anything else I need? Sort of built. Chip's just not broken, I don't think. And that should be built too. What's that? All right. Cluster source. XML. Okay, so that's loading of the data. And then, oops. Start. And then those are my final clusters right there. So, notice I got this funky little loopy thing going on, right? And then I have some debug where it prints out generations. What else? It's funny too, since it's asynchronous, you do get weird things where like you kind of get like error messages printed in batches and like, because this is not the actual, because I started using standard error for my error printing, and since they're two different buffers, it gets kind of weird as far as when they come. It's actually not very helpful until we switch everything else to debug as well. I mean to error as well. Okay, so these are the initial data points. So I'm kind of exercising a few different pieces of our system here. I got
Ha!
does it work?
Look, I'm in my pipe message again.
All right.
Crazy.
Wait, are you jumping up with something that's showing it's broken, or something that's
No.
showing it working?
Well, it's still broken, but at least I didn't get. It did call pipe message event. But from that other one, it's debug, and I can get my message element.
Where?
Well, I just use something. Just do it too. Is it a blank message?
I don't know.
No,
All I know is I don't see any system out.
But it caught the event that time.
Okay, but is there anything in the? I mean,
Oh yeah, you want to see if there's something
Yeah.
in the message. Yes. Send a message and have something in the message.
oh, we haven't even gotten to the parts what I've asked for yet. We haven't even gotten to that. We're not even in the vicinity of things I've asked for yet. We're still at the things leading up to. Okay, so this is my config, which has a data set, right, and then a cluster set. So the data set are the data points that are going to be clustered about these points. Okay, and I have a system of, and I started noticing. Oh, that's not even the current. I started noticing patterns that are similar to what we're doing in parameter sweep. So one thing I noticed is you need to work when you're doing signaling and stuff. Like when you're doing stuff like I don't know, like hey, I'm done doing a batch of things. You need to kind of signal from the tail back, because if you're going through a sequence of things, you don't want to be signaling forward because you don't know what's going on after that, right? You kind of want to get to the end and kind of say, hey, you guys back there, is everybody back there done? Okay, if so, then I'm going to move on. Okay. I also noticed like this factory. I did the same kind of factory idea. In mine, I have two factories. Well, kind of. I have first of all a data factory which takes these points and deals them out individually. And you do that for a number of reasons. One is to throttle everything back so that you don't just send everything to a loop that one of the modules can run through the loop. Okay? And the other thing is that it also opens the door to splitting and sending, right? Because I know how much I've worked on because I'm holding all of the cards and I'm just dealing out the ones that I can work on right now with the worker module, right? So what the factory does is just like our input factory, right? It goes through the list of data points and it will give one out to the data to centroid piece. Now the data to centroid piece is neat because it's something with two slots before it can fire. I have to get the data point and then all the cluster centers that I want. Because what I need to do is I need to look at the cluster centers and find out which point is this closest to. Which centroid is this data point closest to? Because that's how I cluster. If I have a data point that's a number and I have these four numbers, whichever one I'm closest to, I say, oh, okay, you're with that guy. Get another data point. I say, oh, okay, you're with that guy. And I keep doing that until all the points are in their various clusters. Okay? So what I do here is I need a data point in order to start clustering, but I also need all the cluster centers, right? So I have these two slots, and this is another neat pattern right here, which happens a lot, which is wait for two things and then move on. Okay? So if I get the data point first, I store the data point, right? I store the data point that I just received, and then I check if I have the clusters as well. If I have the clusters as well, I move on to clustering. Otherwise, what do? Nothing. Right? I just sit. In other words, I go dormant until I receive another event. Same thing happens on Slack clusters. So this is the first iteration. What do you think I'll need to watch out for in a final implementation of this? What problems are we going to run into checking if data's there or slot if clusters is there? See how we're setting and then we're also reading the values? Right. You could read, and I mean you could clobber something that was being read, or Somebody could still be writing while you're checking this, and then you'd both miss the cluster event, right? You want these to be synchronized, these methods, so that to make sure that none of the other ones are being altered, at least while they're doing those two steps. Okay? Then you go into cluster, which is actually doing this checking with everybody to see which one you're closest to. Whichever one you're closest to, that's the one you become a member of, and then you emit cluster. But notice that I don't emit cluster. Emitting cluster doesn't mean I'm done with all the clustering. That's just saying this one data point is done being clustered. Why? Because cluster becomes the signal, right, to keep pumping out extra data points. Because the data points can keep coming in, and we can say, okay, I'm clustering this one, and we just keep working with the data factory to get as much of it done as possible, right? When we finally get to the end, slot get data, right? When we finally get to the end, we emit empty. Well, what's funny is this guy isn't the guy who receives empty. Is it? Oh, I do receive something. Oh, the empty is just I just clear out my data that I'm holding because just to make sure that I'm not. So that the reason I clear out the data is because if I happen to receive some other cluster centroids, I'd start processing it. I just make sure that I'm clear. Because all I'm doing is I'm sitting here holding all my centroids with all the member points in them. But what I actually do is I wait for move centroids is the thing that's going to grab the centroids and then recalculate the new centers so that we can go through another loop. But I let move centroids pull those clusters from data to centroid. So notice I'm doing this. I'm sending data down to data centroids, right? Data to centroids. I'm pulling data down so that I can cluster them. But then I'm sending back up to say, hey, like basically, I keep sending it back up, and it has to tell me that it's done so that I can know that I'm ready to move on to the next step, right? But then I don't let data to centroid say, oh, okay, I got an empty event, I'm going to send my centroid somewhere. Okay, I let the empty event go down to the next stage so it can pull the centroids, right? So it can say, hey, I want your centroids. I'm ready to work them. Okay. The reason I do that is because if I were to just send my centroids to move centroids, I'm not guaranteed that move centroids isn't doing something else right now. Right? It could be processing the last batch that we were doing or something like that. In this app, it actually couldn't be, but it could be doing something else. So I want to let it ask for the data so I know that it's done. Right? So there's all these different handshakes that you do to say, hey, I'm done. Okay, I'm done too. Let's exchange data. You can't just start sending data because a lot of these slots are storing data inside the object, and you'll clobber that old data when it gets there. Okay, so what I end up doing is I keep going through move centroids that moves them, and then I have another piece which is gather centroids. This is actually the other factory at the top, but gather centroids, data factory, they push down into data to centroids, they go down to move centroids, which loops back up to gather centroids. And then your data actually resets and starts sending the data out again. So what I have is I have this Y shape where I have data cluster centroids coming down, the centroids loop back up, the data resets, and it keeps going like that, like and it keeps pumping through until you go to a number of generations of doing this. And once you get done with the generations, gather centroids can print out the results or emit a signal which goes to a reporting piece. Okay, so the thing is that writing this kind of clustering, this k-means clustering, writing this in sequential, like for a sequential execution, is very simple. It's just a loop. Okay, but what we're doing is we're taking that loop and breaking up into pieces, and the main reason is that we can start doing multiple sections of that loop simultaneously by just splitting up the data. Okay, so now what I'm doing right now is I am wiring in all the remote messaging. And again, I'm also seeing patterns there as well, which is why I'd like to have like a full-blown like query system to take advantage of modeling like the juxta queries more closely with our messaging system, so that we don't go through very big cycles of, hey, I want this. Oh, okay, I'll take that, or I have that kind of thing. Because what I end up doing here is like, for example, with Data Factory. Okay, there's a system here where I'll say, oh, I need some data, right? This is if you were to load up and you don't get any config, right? If you were to join a group, you'd have no data because you don't have the XML config file. You say, hey, I have no data. So if you'd emit need data remote would show up somewhere else, and that would be slotted to need data. Slot need data, okay? We'll say, hey, I have this range available to you, and it will offer it, okay? Offer remote comes in, and that's slotted to offer, okay? It says, oh, that's a better range than I've seen anywhere else. I'll take it, okay? And here's another interesting pattern. This when I emit need data, right? I'm empty, right? I get a start message. I'm empty, right? So I say, oh, I need to go ask for data. So what I do is I create a remote event that is need data. It's just a blank query that I'm saying, hey, does anybody out there have some stuff for me? But notice what else I do. What am I doing down here?
You have a timeout.
I'm,
You never get anything back. You're delaying it.
right. Not only if I don't get anything back, but also how long I'm willing to wait comparing answers until I go with the best one, right? So I do that with a timeout, and then I move on. So what will come back is, one is people can answer me and say, hey, here's what I have to offer you. Well, the offers come in this way. So what I do is I check, is it a better offer than what I already have? In other words, a bigger chunk of data that they're willing to give me than what I asked for from what I've heard already. If I haven't heard anything, then my initial range will be negative, actually. So anything that initially comes in will be better than my initial range. Okay? So if my initial range, I sit there and wait. So I might get an answer immediately from a fast peer who has a small set of data, right? And then I can wait up to my timeout for other offers to come in saying, oh, I have this much to work for you, this much that you can use. But notice nowhere in this offer do I actually accept the offer and start moving on. I don't emit any signals. I don't do any additional processing. Why? Because I'm waiting for the timeout, right? Then I wait for the timeout. When the timeout fires, this is when I now compare. I say, okay, I actually have a legitimate offer. I'm going to start breaking that offer down so that I can actually request it from them. Okay? I'm going to say, all right, I want the range that you offered me, right? And then that will go to I want data, which turns into what? I want data remote on the other end, right? So that slot request, this is the next phase, right? That was just the querying. Who wants it? Oh, I want it. So now we get to the point of, all right, I want it. So we can start moving on to the phase of actually getting the data, breaking it out, packaging it into an object, and sending it to the peer. Now, what's interesting though is that on this clustering, when I send them a group of data, I don't just send them data, I also send them a group of clusters that they're now responsible for. Because I have these two pieces, I actually divide up both. So what do I do? What I do is I do an internal signal to get the centroid information from the object that's responsible for them. So it can actually get them, and then it can pack. I haven't finished coding this part, which is, what is it, slot request?
Slot request at the song.
Okay, so this I haven't finished, but what I'm going to do is I'm going to break out some of the cluster clusters for it to be responsible for, put those into the config that was passed to me, and then I'm going to pass that on. Okay, this will eventually pass. I mean, this is essentially going to be passed on to the actual the actual data to central, or the actual data factory that initially requested it, right? Because that's going to come back as a something. I don't know if I have that signal in yet. Okay, but it's going to come back as a signal with a config object. I can bootstrap myself with that config object. Then what? Pass it on to the move centroids. It can bootstrap itself with the object. Go all the way through, and everybody gets bootstrap. Start, and I start running. Okay. Cuckoo. That's in that is in CVS. If you guys want to check it out, it's just a separate project. So we have a bunch of stuff in there these days, and it looks good.
Now, I just had the wrong name for the message.
Okay. Is it still broken?
Well, I was trying to get you to help me fix it.
Well,
But you didn't believe that I had gotten as far as I had, so now I have to show
oh, I'm being hard on you now. Is that it? I'm
No.
sorry. I'm
No,
so,
you're
I'm
not
sorry. I'm
being
pushing you
hard.
too hard.
Now,
I'm sorry.
Now let me show you.
All right.
I'm going to start the climb up here.
I'm sorry I'm pushing you too hard by providing you with a working messaging system already in the project, and you just need to extend it.
Alright, see? We got the. Alright, I'll start
Okay.
from the client. Now I'm going to start the server. Watch it not work this time. Alright, see?
Okay.
I got the event, caught the event. Prints out. That's what I sent the file name.
Okay.
So that part works. Now my problem is, uncomment this, and actually just for, I'm gonna add this, just to be, like,
You can come on in. We're almost done.
and then, what's the syntax if I just want to initialize it with numbers? Oh, what is that? 1, 2. Can I do that? Or
There should be dimensions.
brackets?
I could do
Probably
the pros. Yeah. All right. We're gonna check. I'm gonna check out Richard's stuff.
Alright, how about I just do new byte 3 because I don't know the syntax.
What's that?
stuff?
Next week. I expect something from each of you.
Console.
Either presentation on stuff you've coded or presentation on papers.
I can put a 2 right there, right? So that's 2. I'm just gonna do it.
So
Alright.
I don't know if I can do Code Jam this week. If we do it on Thursday, I really gotta go to work.
Coming up, brother B.
Negative broke.
Alright.
Or which may not work. Whatever, like alternative broke. Just do what you gotta do. Look it up. No more.
Alright. So I should be good, right?
Either way, I'm
Yeah.
on Thursday anyway. Okay, cool. Might just be like 8 finish. Shoot, good. That works out. I'm gonna do something.
Now watch how.
Dude, I'm not giving this back. I stole this hoodie from my brother.
Watch how it doesn't fit in this.
It's so warm.
Alright.
I
And then on that part,
See
and
ya.
then on that part, right, is when it would start printing out the data from the byte array.
Yeah.
Okay, sweet. All right, well we're done with that then. Sweet.
So I guess there's something.
Something wrong with your file I/O.
Yeah. Oh, thanks.
For what?
That's a lot further than I was when I got here.
Huh?
That was a lot further. I
If
didn't
you're
know.
saying thanks for me not believing you, then you're welcome.
No, thank As a professor, you need to know what kind of support to give us.
See, I immediately will not listen to you if you say, "Well, nothing's changed." Okay, because what you're telling me at that point is you don't believe in deterministic machines, and I just can't.
Oh man, I figure
No, so I mean, if it's just the file I/O stuff, then yeah. But you weren't printing out anything from the array to make sure there was stuff in it, or
there's like my problem was that the event never got caught.
okay. But I mean, if that's happening though, that the event is not reliably being output. I mean, because I was doing that too. Like I said, you wanna.
That's what I'm saying. Like Jupster, I guess there's some kind of error that I never found out about.
It might be, but yeah, take a look at through. What I do is I'll pretty much run one of my sides, because we moved away from the client server where you can really debug either side to see everything. But I'll debug one of my. I'll set one of the juxta setups on one of my sides to print out debug messages, and then I'll just run it, but I'll just log it to a file. I'll just redirect it to a file, so anytime I run into problems, I can go back to the last run. But you'll see, I don't know, because I did notice that it was doing some of the I was missing some of the thrown events and stuff, but I think the log juxta kind of logs its own exception. What's that? Yeah, it's just debugging. I don't know what level it starts pulling out. And then also the other thing that's helpful about that log is you'll see, even if they're not your events, even if they're not your juxta messages, you'll see juxta messages that are coming from the other client. So at least you know that the network, you're like, you sit there and go, okay, at least I know that they're seeing each other, at least something on the network, because I don't know. The thing with the main problem with Juxta is it tries to be too smart and it's not smart enough types of things where it's not gonna exactly tell you like there's no explicit binding. I'm going to this address and support you. So it's like, well, you can, but I mean, it kind of defeats the purpose of it. So it has to all be automatic. And if it's all automatic, then that's fine when it works, but when it doesn't, it's really hard to debug. You don't know what all the mechanisms that it's going to go through and it takes time. But, like you, like I was doing some of that stuff, I noticed it. Like, you remember when last time I was saying, okay, well, I'm looking through the application stuff, and sometimes they talk to each other, sometimes they don't. When I started doing stuff like fixing, advertisements, or naming them something specific, or making sure that I'm looking for a specific set of advertisements, or just any advertisement, and that's like the discovery type, and then also like keeping the same type names and stuff like that. Then it works every time, it started getting, solidifying. So now that like I said, what I recommend is once you get done with your client server thing where you can see data transfer and say, okay, I now know that this can reliably transfer a stream of bytes from one end to the other. Then you can basically just model off of the case model and then just build the new object for the file subsystem and then wire in your pieces and keep it good to go.
That's what I was gonna do. But I wanted to use the query because I like it as well.
Yeah, I like the query too, but I'd also like to expand uses of the query to have basically a separate remoteable event type that is query. Mainly because that query is so much more efficient than in the sense that it handles two transactions instead of just one. So we're going to need to, I don't know, it's going to be hard though because that query kind of depends on the stuff in the query handler being available to both sides. I mean, like, you handle both sides, but we don't have that kind of tight coupling between an application object and the query handler, you know what I'm saying? Because we want the query handler to receive the queries and send the responses, but we want the actual logic to be handled by like a parameter sweep object or something like that. So I
I don't know if we'll have to tweet and like actually give a period handler, but yeah, all that different stuff, all the examples in the like all the old styles of calling stuff. Some of the good stuff I found was on the mailing list. I don't know if you checked out the mailing list archives because tons of people go to the mailing list, on that mailing list and they say, hey, I tried the example from at and stuff like that programming guide. I tried this example and I get the period the duplicated called and like, oh, and this through this exception and that. And then they'll say, oh, here's what you should actually be doing. Here's the new style of doing it. So basically, the mailing list is the transition between the old bits of programming guide and, I don't know, wherever they're at. I agree. It's a mediocre library at best, but it covers a lot of ground. So, right. But what I want to think is that really to be able to find out what exact functionality you like about that broad thing, you can write like a smaller, leaner networking system that's just implement that. You know what I'm saying? So like you can get to a point where but you don't really want to run into, oh, I need this functionality, let me write it. Whereas it's just you say, oh, I need this functionality, let me just grab this and do it. And then you get to the point where you're like, oh, this is so slow starting up, and I don't know exactly where the tools are, and all these stuff. So then you just kind of say, okay, well, I'm going to replace tracking to a board, I'm going to replace, But I mean, people will do it with like these queries and stuff like that. These queries, yeah, you just like, I want this with small, lightweight message, and then whoever responds, you get after you get your queries, you get your adjustments, and then you can put it in your rank. I know you do. No, but I know you do, but if I don't drive it, it doesn't get done. So I mean, I have to drive it, no matter how hard you're working and stuff like that. So I see stuff that can go back into the code base that we can start using. Doesn't matter how hard you're working, right? Because you become these critical points where these points where we can't get past some other things. So those, just like with the big, the big subsystem, I really need, making sure shut up because I have to start hard coding everything and, in different apps. So, yeah. But see, did you see what harassing you did? See harassing you, like, cracking a little bit? Now, all of a sudden, now, now I got file structures, like, like, just need to be, just rigged into the rest of the subsystem and then done. Huh? You know what? I wish I didn't have to say it. That's actually why I was like, I've been doing contract work and like supplements and stuff like what we live off like a department stipend and stuff. So like I was doing contract work and it just tears me up. Yeah, I gotta do the same thing and like putting in my role doing this and wake up and go do that. Alright, see you.
Shh.